Alright, what if it's a fraction like 1/4 that you have to turn to a percent or a decimal? Option 1, turn the 4 into 100. Since the word percent, per means part and cent means 100, is parts of 100, percent, parts of 100. So you could go 4 times 25 is 100, 1 times 25 is 25. Whatever you do the bottom, you do the top, right? So that would be 0.25 or 25%. Your other option is you could go 4 into this 1. So you'd put 4 into the 1, put a little decimal point, because you're going now 4, which is bigger than 1, so 1.0, and then just start bringing, adding some zeros to get you there. So 4 into 10 is 2, put 8, subtract, bring down, and you get the idea. So if you had to turn a fraction to a percent or a decimal. Alright, chapter 10, two-dimensional figures. Acute, it's so cute. Obtuse, oh boy it's big. Right, perfect 90. Array goes in one direction, straight line. Line of symmetry, same on both sides, however you fold it. There's also, I was going to say rotational symmetry, but if you rotate it, if it looks the same each, so this flower would have rotational symmetry. Every time I rotate it, it looks the same. Okay, polygon. The rules are it has to have sides, no curves, and it's closed in. So that is a polygon. This one is not, because it's not closed. This is vertices, which are your corners, and then parallel lines. In the word parallel, you got the two L's that never ever meet. Okay, intersecting, they are basically all of your crisscrossing lines, perfect crisscrossing lines. Perpendicular, or crisscrossing lines, perpendicular are the ones that create a 90. They're like the perfect crisscross. They've got 90, 90, 90 all the way around. Sides, lines, line segments, triangles. If it has one obtuse angle, it's obtuse. If it's doesn't have any, it's acute. And then if it's got that, it's a right. This is the one that I like to remember, EIS, which is alphabetical order, equilateral, isosceles, scalene, and then count down like a rocket ship, 3, 2, 1. And it kind of gives you an order. Equilateral is 3. It's this isosceles and scalene that's always hard to remember. So isosceles 2, witch's hat, looks like witch's hat, and then scalene is the one that doesn't have any at all. None of them are the same. Triangles, 3 sides, quadrilaterals, 4, pentagon, 5 sides, hexagon, and all of these are also known as regular polygons, because all the sides are the same. Decagon, trapezoid, I always remembered like a trampoline, you're jumping on the trampoline, but the rule is it has to have a pair of parallel sides. Parallelogram, you get that. Rhombus, think of it like a square that's been squished. This isn't a perfect one, but you get the idea. All the sides have to be the same. Rectangle, square. The square is the cool guy. A square can be a rectangle, but a rectangle can't be a square if you follow the rules. Vertical lines, horizontal lines. The other day we talked about vertical. Like when you do the letter V, you're doing vertical lines. On the word horizontal, you have to draw one horizontal line. So that's kind of one way to remember it. Letters with symmetry. All these guys have vertical symmetry. All these had horizontal symmetry. So that way, these guys you could cut. These guys had both. So up and down crisscross. And then these guys were the nuns. Nuns. They didn't have any at all. Angles and turns. This is clockwise. Going around like a clock. Counterclockwise. When we get into the angles. Looking at this angle, this is bigger than 90, and so when you line it up on your protractor, you're given the option of, would it be a 20 or a 160? So when I line that up, it's going to end up over here, and I'd see two numbers. I'd see one that says like 20, or I'd see one that says 160. Now you know it's bigger than 90, right? So the option is 160 versus a 20, you know it's going to be a 160. Oh boy, it's big, right? If it were like this, and I had two options, my two options being like a 50 or a 130, then that guy's smaller than 90, so that's got to be a 50 when you line up for protractor. Your turns, a quarter turn, 2 quarter turns would be half, 3 quarters. Get the idea. They also use it like in the military or on compasses, or like the wind or whatever. They'll say the wind is coming out of 135 degrees, and so that tells you that's a southeast direction. So a little bit beyond math there, I guess. Your triangles, all of your triangles add up to 180, which is kind of cool. So 60, 60, 60, that's equilateral triangle. That's going to be a 180. You add up all these numbers, and it gets a 180. You add up all these numbers, and that gets you a 180. So the cool thing about that is if they were to give you like 2 angles, then you could go and find the other angle. Okay, 2 angles together, 60 plus 40 makes 100. Add all that up, and it makes 140. The thing there is, like, when you start doing like straight, you know that this straight line is 180 degrees. So let's say that this angle here was like a 140 or something, then this angle would be what? 40, right? Because 140 and 40 make 180. So that's helpful. Okay, on a square, you know that all these are 90s. So if they cut that square in half, and you're cutting 90 in half, half of 90 is 45. So you know that these angles here are 45 degree angles. That's going to help you a little bit more in like 5th grade. Rectangle a little bit different, but you do know that these are 90s, right? And so one of these angles has got to be bigger because it is slanted. So that would give you at least an estimate that that guy could be 70 and that guy could be 20. Probably about 6th grade you'll start figuring out how to actually find the real deal answer, but for now, close enough for an estimate. Alright, here's our straight line, A to C. This is 75 and 85. You add that up and you get a 160. So what's missing? From 160 to a 180 is 20. So there you go. What's the angle measure? You just grab a protractor. On the inside it would be a 135, and on the outside it would be a 360. Let's say they wanted to find out what that is, and you know the inside's a 135, and you know also that it's 360 degrees to go around, you could go 360 minus the 135, which equals your 225. Pretty cool, huh? And you could do the reverse. If they gave you the outsides, then you could do the inside. Talking about a clock, splitting it up into fractions of a piece. There's 12 numbers on a clock. If you were to split each one into a pie piece, that gives you twelfths. So that would be 1/12. And I mean, really, that's about it for the fractions of the clock. You can read more of that on your own. Just trying to go quick again. Oh man, here we get into measurements. Metric. Length, you're going to go with the meter. Weight is your gram. Volume is your liter. Your kilometer would be about a lap around Tiger Point. A meter is about a baseball bat length. A decimeter is your hands, about the length of a hand. Centimeter would be about the finger width, maybe a pinky width on an adult. A millimeter is like a pencil point, so really small. Gram, starting at the kilogram, it's pretty heavy. It's about like the weight of a textbook, maybe your math textbook. So like, just to let you know, like I weigh like 78 kilograms, which is about in like, that's about 175-ish, 78-ish pounds. So just to let you know. So most of you guys are going to be weighing around probably half of that. So you're probably around like 40 kilograms. Gram, which is the weight of a paperclip, or they said dollar bill, but I always go with the paperclip idea. How heavy is a paperclip, pretty light. A liter, so this is going to be your volume, a large bottle of water, or we have 2 liters of Coke that you guys buy at the store all the time, so half of a 2-liter bottle of Coke. So think about that, like a big bottle of Coke, and then cut it in half. And then a milliliter is really small, basically think of like a dropper. Or last year we kind of figured out from a Germex bottle, like the little squirt ones that you do, like, and it squirts, that's about a milliliter. Maybe a little bit more, but you kind of get the idea. Okay, one thing that I like to use for the metric system, because it's on the base 10, is King Henry died by drinking chocolate milk. And so it's King Henry died by drinking chocolate milk. That's the easy acronym. Now it stands for kilo, hecta, deca, base. These are your grams, your meters, or your liters. The deci, the centi, and the milli. And I put these guys big in capital letters because those are your big guys, and these are your smaller guys. So the further to the left, those are the bigger units, and the further you go to your right, the smaller. So down here, King Henry died by drinking chocolate milk. 1 liter, let's say they want you to turn into milliliters. So you go to where liter would be. Liter would be here at the base, because that's your base. It's either going to be meters, liters, or gram. Your base is liters, and you're going from liters to milliliters. So bunny hop over to milliliters. So 1, 2, 3 bunny hops to the right. So my original was 1. I'm going to go 3 jumps to the right, which was 1, 2, 3 zeros. And boom, I'm done. 1 liter is the same as 1,000 milliliters. Okay, what about 4,156 grams? Well, that's from grams. Grams is going to be your base, because it was liters, meters, or grams. Grams is your base of weight, and you want to go turn it into kilograms. You're going to go 1, 2, 3 bunny hops to the left. The original number was 4,156, so I would have a decimal there and go 1, 2, 3 hops to the left, and that gets me at 4.156 kilograms. And there's your kilometer to meters. And that'll work for everything in the metric system. That's why metric is one of my favorites. Which brings us to customary in the U.S. Yay, go USA! Except customaries, I think, are a little bit harder for kids. Length, you got your inches, your feet, your 3 feet equals a yard is about a baseball bat, mile, 5,280 feet. This one I always remember, just because it helps later. Weight, you got your ounce, which is about a slice of bread. 16 ounces is a pound, so if you thought of like a loaf of bread, that would be about a pound. Next time you go to the store, pick up a loaf of bread, that weighs about a pound. A slice of bread is an ounce. If you got 2,000 pounds, so you could say 2,000 loaves of bread, sounds crazy, but 2,000 pounds is about a ton, which is about the weight of a small car. You got ounces, which are small, like a small personal ball of Germ-X, like those little ones that sometimes people carry around. 8 ounces is a cup, and I put 1 milk, which is basically 1 milk at school. 2 cups equals a pint, which would be 2 milks. If you look on your, oh, I don't know. Sorry. 2 pints equals a quart, and then 2 quarts is half gallon, and you're like, oh man, this is so complicated. But here's the easy thing to remember. The big G. I love this big G. So big G stands for gallon, and then in that is 4 Q's, 4 big Q's for quarts. In those are your P's for pints, and in those are your C's for cups. So, question, how many gallons is 10 pints? How many gallons is 10 pints? Count out 10. 1, 2, 3, 4, 5, 6, 7, 8. 8 would give me a gallon. So that would be 1 gallon, and then I'm going to count out 10 pints, so 8, 9, 10. So it wouldn't be 1.5, it would be 1 1/4. 1 1/4. But you get the idea, right? So you can use this to help you. How many cups in a gallon? So in this big G that stands for gallon, look at all your C's. You got 2, 4, 6, 8, 10, 12, 14, 16. How many pints in half of a gallon? Cut that gallon in half. How many P's do you have? 1, 2, 3, 4. 4. Done. Okay, comparing. On these, you're going to have to change something. So this says 13 feet, 5 yards. Turn your big guy into the smaller. So 5 yards, turn him into feet. 5 yards, so there's 3 feet in a yard, so 5 times 3 equals 15. So now you can say that 15 is bigger. What about pounds to ounces? This is saying pounds, this is saying 40 ounces. Turn the pounds into ounces. How many ounces in a pound? 16. 16 times 3 equals 48. Now it's an easy comparison. 27 feet versus 9 yards. Turn one of them. I'd go with this 9 yards. Turn him into feet. 9 times 3 is 27, so those guys end up being equal. How many seconds are in a day? We'll save this for next.